Welcome to Robinson Foundry. In a previous video, I showed you how I made this awesome aluminum and bronze dual-threaded bolt by turning a 3D print into metal. This thing turned out really cool, and I play with it all the time, and because it's super loud and annoying, it drives my wife nuts. So inspired by how fun this thing is, I decided to try and design something equally as unique and annoying to play with. After a few hours of CAD modeling and 3D printing, this is what I came up with. In order for nuts to work on these crazy bidirectional threads, I had to design them with a single row of threads like this. After testing the 3D printed version to make sure it worked properly, I printed all the parts that were needed to turn this bolt into metal. To make this bolt, I used a process called lost PLA. In this process, plastic 3D printed models are used as positives to create ceramic molds, and then they're melted away in a kiln and replaced with metal. This big funnel-shaped thing is a sprue feeder combination. It'll act as a funnel, helping me to pour in the metal, and it will also feed the casting with molten metal as it solidifies and shrinks. The nuts will be cast from the bottom to the top. Metal will flow down through the center sprue and rise up through each nut and out the vents. This stuff is called Suspendaslurry. It's a liquid ceramic that's used to create ceramic shell molds for metal casting. I dip the models into the slurry, making sure to avoid trapping air bubbles on the surface of the models. My goal was to slowly build up a thick shell by coating the models with slurry about 10 times. The first few coats are the most important, as this is where the fine detail is captured. After letting the first 2 coats dry, I sprinkled each subsequent coat with silica sand and allowed it to dry before adding another. After the 4th coat, I wrap the shells with very thin steel wire. This acts like rebar in concrete and helps to prevent the shells from cracking during the burnout. I allowed the shells to fully dry for a few days and then place them inside my kiln to burn away the plastic and turn the shells into ceramic. These models were printed using a plastic called PLA. PLA works great for this casting process because of its relatively low melting point and ability to be burned away without leaving any ash behind. I use Overture Black, and I can tell you from experience that it burns away very cleanly. It wasn't my goal to just stick these in the kiln and let all the plastic burn away into the atmosphere. So instead, I turned on the kiln and brought up the temperature very slowly to about 500 degrees Fahrenheit, which is the temperature at which the PLA starts to melt out of the shells. When the majority of the plastic had melted out of the shells, I opened the kiln and removed it. Then I cranked up the temperature to around 1500 degrees Fahrenheit. This vitrified the shells, turning them into ceramic that can withstand the temperature of molten metal. If you enjoy watching these videos and want to help me continue to make them, you can do so by taking a look at some of the affiliate links in the description. I'll list items that I've used in this video, as well as products that I would recommend. The next day, I inspected the shells and I was happy to see that none of them had cracked substantially. At this point, the shells were almost ready to be filled with metal. They just needed to be preheated to about 1000 degrees Fahrenheit, so I placed them back into the kiln for a couple hours. The nuts were cast in bronze, consisting of 90% copper and 10% tin. The tin I used is actually lead-free pewter, which consists of about 95% tin and 5% antimony. First I melted the copper, which took about 30 minutes in my homemade furnace. Once the copper was completely melted, I added in the tin to create bronze. I let the bronze heat up to about 2100 degrees Fahrenheit, pulled the shell out of the kiln, and poured in the metal as quickly as possible. I cast the bolt next, but this time I used aluminum, which has a much lower melting point and only took a few minutes to melt. When I was done, I submerged the castings in water to help cool them down. Unfortunately, this didn't soften the shells at all, but it did help keep the dust from floating around as I broke apart the molds. Breaking open these ceramic shell molds and getting to see what the castings look like for the first time is one of the most rewarding parts of this process. But sometimes removing these shells feels like a whole project in and of itself. It tends to stick inside every crack and crevice, and removing it is easier said than done. I was able to remove most of the shell by breaking it off with a hammer, but I had to blast the rest off with a powerful pressure sprayer, which works really well, but every time I do this, I end up getting completely soaked. At this point, I was able to see that the castings turned out really nice looking, and I couldn't wait to start cleaning them up. First, I used a hacksaw to cut off the sprues and excess metal. Next, I used some hand files on the outside of the nuts and bolt head to get rid of the visible layer lines from the 3D printing process. Then I smoothed them out even more with some fine grit sandpaper. At this point, the outside of the nuts looked great, but the insides were still unfinished, so I used a sandblaster to clean up all those hard to reach areas. The final step was to use a bench grinder and polishing wheel to give these castings a mirror finish, and they were done. I'm extremely happy with how this thing turned out. I was really hoping that the threads on the bolt itself would be nice and crisp, and they are. It almost looks like this was machined or 3D printed in metal. Isn't it cool how you can see all the 3D printed layer lines? Alright, let's check out how this thing works. The nuts effortlessly slide down the threads and change directions in an instant. I'm amazed at how well these things work. It actually ended up being a great demonstration of inertia and momentum. I can play around with this thing for hours, which makes it a great desk toy and an absolutely annoying one to listen to. It should make my wife really happy. I'm considering selling 3D printed versions of these bolts, so if you're interested, take a look at the description for more information. If you have any suggestions for things that I could make, please let me know. I'm always interested in new ideas. I hope you enjoyed watching this video, and if you did, please give it a thumbs up. Let me know what you think in the comments, and subscribe for future projects. Thanks for watching.